Hi class, welcome back. Today's topic is inverse matrices. We're going to go through a few vocab words first, and then we're going to jump into on how to find the inverse of a matrix, as well as how we can use inverse matrices to solve systems of equations. So there's kind of two parts to this. So let's start off with the identity matrix. The identity matrix is a square matrix, that's important, that acts like the number 1. So the identity matrix looks something like this. Remember, it has to be square, which means same number of rows and same number of columns. And the only numbers that are in your identity matrix are 1s and 0s. And along the main diagonal is always going to be the 1s. Everywhere else would be 0s. And this works for any size matrix as long as it is a square matrix. So it could be a 3 by 3 or a 4 by 4 or a 5 by 5, doesn't matter. So notice, same thing, 1s along the main diagonal, 0s every place else. And the reason we even have an identity matrix is because you could multiply the identity matrix by any other matrix and it won't change your answer. So it's like multiplying 5 times 1 will always still get you 5. So if I take a matrix times the identity, it will get me the original matrix. So where this identity matrix is useful is if I give you two matrices, maybe I call it matrix A and matrix B. If I multiply those together and I get the identity matrix, which we always use the letter I, then that means that A and B would be inverses of each other. So you could think of it like if I take 2 times 1/2, we know that we get 1. So that means that 2 and 1/2 would be the inverse of each other. Okay? So same concept, now we're just doing it with matrices instead of just simple numbers. The notation that we use for the inverse is written here at the bottom. It's a to the power of -1. So a represents the name of the matrix, and then -1 is always in the exponent. So we always want to use capital letters when naming our matrices, and just know that it won't always be A, it's whatever the letter is for the matrix. So in our first example, it says determine if the matrices are inverses of each other. The only thing we have to do to determine this is to multiply them together, and if we get the identity matrix as our answer, then we know it's an inverse. So let's go ahead and practice that matrix multiplication. So remember, when we're multiplying matrices, we're going to do row to column. So I'm going to take -4 times 1/4 plus 2 times 1/2. When I multiply that, I get -1 plus 1, which is 0. And then I can do the same thing. Move on to the next one. So row 1, column 2. So that's -4 times -1/2 plus 2 times -1. So that's going to get me +2 minus 2, which is 0. And already I could tell you that this is not going to be an inverse, because remember, the inverse matrix, or the identity matrix, the identity matrix always has 1s on the diagonal and 0s everything else. So right here, the fact that we don't have a 1 is a red flag. So we could go ahead and stop here and say that they are not inverses. Now, if you get a 1 and a 0 to start, you need to keep going and make sure you multiply them all the way through. You still want to make sure you understand how to do the matrix multiplication, so if you've forgotten that, make sure you review that back in section 2. But you would have moved on to row 2, column 1, and then at the end you would have done row 2, column 2, and those would have been filled in the bottom spots of your matrix. Okay? So if you have any questions about how to tell if they're inverses or not, let me know, but it's just matrix multiplication. Now, we're actually going to practice calculating the inverse. So to do this, I've went ahead and written the generic formula that you would need for an inverse, and then we're just going to jump in with an example. So here, they're telling you that matrix A is a square matrix, and I just put letters in for all the numbers you would have, so A, B, C, and D. To find the inverse, you're going to do two things. The first thing is you're going to find the determinant. And that is from the last section where we talked about Cramer's rule. Okay, so you're going to find the determinant. Then the other thing that you're going to do is switch around some things from the original matrix. So notice that A and D switch places, okay? And then B and C change signs. So they don't move spots, but they just change signs. So if it was a positive, it becomes a negative. If it was a negative, it becomes a positive. So the main diagonal switches, and then the other diagonal changes signs. So what we're going to do is have 1 over our determinant, so this will be some kind of fraction of some sort, times whatever this matrix is here. And whatever you get when you're done from the multiplication, that would be considered your inverse. So the easiest way to do this is to just kind of go into an example. So to find the inverse of this matrix P, first we're going to find the determinant. So remember, determinant means we multiply the diagonals. So if I take 7 times -1, that's -7. 2 times -5, that's -10. And then remember, we always do bottom minus the top. And that's going to get us +3. So now if we look back to our rule for the inverse, that means we're going to have 1 over our determinant. So 1 over 3. I went there. And then the part that's after is where we do our switching. So we're going to switch the main diagonal. So 7 and -1 get flipped. And then on the other diagonal, we change the signs. So -5 becomes +5, and 2 becomes -2. And now all we have to do is multiply these things together. So for the inverse, we'd have 1/3 times -1, that's -1/3. 1/3 times 5, that's 5/3. 1/3 times -2 is -2/3. And 7 times 1/3 is 7/3. And there's your inverse. And you could always check this. You could take your inverse times the original. So take my inverse here times my original, and it should end up getting you the identity matrix where you have just 1s and 0s. If it doesn't, then that means that there's something wrong with one of your calculations, either the determinant, or maybe you switched a diagonal incorrectly or didn't change a sign. I'd also suggest that you always leave your fractions as fractions. It will make your answers more accurate. Don't change anything to decimal form. Okay? So that's it with actually calculating the inverse. I would encourage you to try this example here. Down at the bottom, try to find the inverse of matrix Q. And then in the next video, we're going to use these inverses to actually solve systems of equations.